Good morning, eighth graders. This is just a reminder if you haven't done it already, please complete your weather log for the day and we will get going into weather fronts. So, weather fronts, these are essentially the air masses that bring our daily weather with it. So, we are going to explore all of the different types of weather that can happen. Like in the present of the air masses moving in as well as moving out and what weathers they bring with them. So by the end of this, you should be able to hopefully identify the different types of pressure systems that are moving in and out because they have a lot to do with our air masses and weather fronts, and then identify the types of weather fronts and what weather follows. So what's being pushed out, what's coming in, what's happening in the meanwhile, all that kind of fun jazz. So make sure you have your notes out in front of you and we will get started. So we need to understand that the importance of a pressure system. We constantly see maps similar to this, maybe not as many lines. But whenever you're watching the weather, you see these giant H's rolling in or these L's and all this or whatever. And essentially what that is the difference of how our air is moving. So weather patterns are directly influenced by the pressure systems. So whether it's a high pressure system or a low pressure system, knowing about these pressure systems can help you forecast the weather. So when we're talking pressure systems, we are essentially talking air pressure. So we already know, and like if you take a peek at this diagram here on your right, it explains it. We know that at sea level, our air pressure is much, much higher. Okay, this is where all the gravity is essentially trying to keep us. But as we increase in altitude within our troposphere, our pressure itself isn't as strong because the gravity isn't as strong, to where it's less pressure, a little more spread out, all that fun jazz. So let's talk about the difference between a high pressure system and a low pressure system. So a high pressure system is the air under high pressure is moving out and away from the center. So it's being pulled down from the top layer of our troposphere. It's being pulled down and then spread out amongst our surface. This tends to be because you're pulling it down from the troposphere where it's really, really cold. It's pulling this dense, cool air that's sinking toward Earth's surface. Typically, when we're moving from cold to warm, this brings clear skies and fair weather. This is the nice weather. That's why today is April 8th of 2025, and I can say we have this gorgeous high pressure system that has finally kind of moved in because it should be around 50-ish degrees, clear skies, gorgeous weather, and it's been kind of cold and icky the last couple of days. But that is because we are having that cold air being pulled down from the high pressure system, from the top layer of the troposphere and spreading out amongst our surface. Can't really condense cold against cold, so that's why it's creating this lovely weather. A low pressure system, on the other hand, is essentially taking that warm air from the surface, because remember, it is warmer at the surface than it is in the upper level of our troposphere, taking that warm air and forcing it upward. So if you force warm, moist, relatively, air upward, then it starts to meet with the cold layers of our troposphere. And this is where it starts to condense. We get really cloudy, chances of precipitation. Oh, excuse me. All of that kind of stuff going on. So low pressure systems, which is what we had to move in, that's why it got like that weird cold, like, ugh, for the last couple of days. And that's because we're taking that warmer air, forcing it upward, creating these clouds and condensation and possibilities of precipitation, snow at this time of year. But this is what happens in the summer when like we go this like really nice stretch of nice warm weather, and then all of a sudden it's like downpour and all that. So those are the difference between high pressure systems and low pressure systems. Essentially, it is taking the either more or less dense air and moving it. So creating just this little area of intense pressure or not as much pressure. So that's it for whole group. We really just need to understand those things before we kind of move in. Now, the next portion might be a little bit of a review if you're sticking with me for lecture. But if you are moving on to text, video, doodle, whatever, just make sure that you have your good understanding of high and low pressure systems. Complete your notes independently. You'll do great. If you need anything, give me a holler. But if you're sticking around for lecture, let's get going. So, air masses. We've already talked air masses a little bit. So these are large bodies of air that have a uniformed weather property. Okay, we have talked about like how, oh my goodness, excuse me. We have talked about how air towards the poles tends to be more dense, tends to be cooler, all this, versus air near the equator is warmer. And that is because of the uneven heating that our Earth receives. And especially up in this latitude, we just have less direct radiation during the winter compared to summer and so on. So those are what air masses are. Air masses can be classified based on where they formed, okay? And then the temperature and moisture content that it can hold. So there are 5 different types of air masses, and they all kind of tell us where they have formed. So anything that says maritime. Maritime is just a fancy word for saying at sea. So this is over large bodies of water. We're not talking Great Lakes sized bodies of water. We're talking oceans and gulfs sized bodies of water. Continental, obviously, it formed over continents. It formed where there is much, much less water surrounding to where it tends to be drier. Okay, and then we have the difference between polar, cold, and tropical, warm, and all of that. Okay, so we have maritime polar. If you take a peek, there are 2 places we are seeing maritime polar, just here south of Alaska. So forming within the Bering Sea. Is that the Bering Sea? I believe that's the Bering Sea. So that, and then we also have some over here above the eastern portion of the US. These are maritime polar. They tend to bring cold, moist air. Okay, so maritime over water, so it's going to be more moist. Polar meaning cold, not frigid, but cold. So that. Then we have continental polar. So this forms over most of Canada. This is what we experience. So it's cold air, but it's forming over land, so it tends to be much drier. This is why we don't get a whole heck of a lot of snow unless we have this weird maritime polar that just whoop, which is what happened to us a week ago. Okay, and then we have Arctic. Arctic air is frigid air. This is very, very cold. It forms over the poles. Oh my God. Ugh, excuse me. I'm so sorry for all the yawning. But Arctic air gets pulled down from the poles. This is what happens during our polar jet streams. where the jet stream just gets so fast and a little wild where it kind of swooshes down underneath, where it typically tends to sit. This is those like negative 35, 40-degree weather days. Okay, then we have maritime tropical. So these are forming around our oceans. So we have the warmer Atlantic portion, the Gulf, and we have the warmer Pacific. Again, these tend to be far more moist and warm because we have the equator just down here. Okay, so those bring more wet, rainy weather, sticky, humid weather, that sort of thing. And we do get a little bit of that. So anything big forming down here tends to come up slightly in our direction during the summer. And then we have tropical or continental tropical. This is our dry, so it tends to form over like Mexico for us. And then this brings us our arid desert sort of weather. So this is what forms and kind of hangs out over like New Mexico, Arizona, like Texas, those sorts of things. So those are the five different types of air masses that the U.S. experiences that can bring different weather. We've already kind of talked a little bit about it throughout this unit. So with those air masses moving in, there is a point where you get some back-to-back silliness. So we have like maritime polars and continental polar air masses that can just kind of butt up right next to one another. Let's talk about what happens then. So, where two air masses meet, those are boundaries. We call these fronts. Okay, this is where you can get a really dramatic weather change for like those couple of days. That's where these two air masses are meeting and they don't blend together. Because there's so much of each of them, it would take forever to blend together. And B, because of our wind belts and our jet streams, it doesn't really have time because one is getting pushed while the other one's coming in right behind it. If you kind of think of like a train, that's what's happening. It doesn't really stop moving. They don't really blend with one another. They are separate cars following one another and being pulled along by one engine. Our engine just happens to be wind. So this is the weather. So the weather before the front has moved through and is often opposite of the weather after the front. So there are four different fronts that we tend to see. We have cold fronts, warm fronts, stationary fronts, and occluded fronts. We're going to talk about all four of those more in depth, but these are the symbols that we use to identify what type of weather is moving in versus what has moved out. And how they're moving. Some are moving quickly, some aren't moving at all, or if they are, it's like millimeters. Things like that. So all of these colors tend to be the same no matter what weather maps you look at. You can look at your city that you've been documenting for the last couple of days, and if you click on the last tab, I think it's called like weather bug or something like that, you can see these sorts of maps with these fronts going over your location. I would actually recommend doing that. I find it pretty interesting so you can kind of see the inner workings and what like meteorologists are looking at. Oh my goodness. Whew. But cold fronts, always blue. Cold is just associated with blue versus warm is always associated with red. And then stationary fronts is every other. Because it's typically a warm front and a cold front that just won't move. And then occluded is purple because these ones kind of blend in together nicely, but also not nicely. We'll talk about those. So I would make note of those colors. Yeah. So a cold front. Okay, simple sort of a thing. We're going to talk about the air that's moving in. So, forms when cold air masses move toward warm air masses. Okay, the warm air tends to get pushed upward somewhat rapidly, and this is because it's less dense than cold air. So causing the air to kind of cool where those two boundaries are meeting, to where this brings like our severe thunderstorms that also result in kind of cool, dry air afterward. If you think of in the summer when we have those super hot, muggy days where you step outside, it's like, oh, I just stepped out of my shower and this is gross. And then we get those major storms. Let all the precipitation out. I always joke with Will, I'm like, the sky just needs a good cry and it'll feel so much better afterward. Because you have all that warm, moist air and then a cold front moving in, forming this giant thunderstorm, letting out all the precipitation, and then you just have this dry air. This is like the cozy, like, oh, this is what summer is. So these pictures kind of depict how the air masses are moving in. So cold air is much denser, so it tends to kind of sink lower, forcing this warm air upward, causing these great big cumulonimbus clouds to develop and release rain. This is kind of the same sort of thing. So if everything's moving in this direction, you have the warm air front, the cloud development due to the frontal lifting of the warm air, fancy terms, just forcing it upward, and then the advancing cold air coming in behind it. So in this case, the cold air is typically moving a little bit quicker than the warm air, and that's why it can kind of push it upward to form those clouds. So that's a cold front. When you see the symbol, you can see it down here. Everything, like all the points are moving in the direction the air is moving. So you can always kind of tell which way the air is moving based off of the little like symbols on the side of the curve. So keep that in mind. Okay, so those are cold fronts. Warm fronts. So again, this is where we get advancing warm air behind a cool air. Sorry. So warm air fronts form when warm air masses move toward a cold air mass. Okay, the warm air gradually rises. You can kind of see because yes, the warm air is moving faster than the cold air, but because the cold air is so dense, it just kind of forms this like ramp above it. This tends to result in cloudy conditions and widespread rain or snow with a like warmer, damper air afterward. So these are like where it rains for just a couple of days, kind of overcast and icky. It's not like the fun, let's go outside and hang out, or, oh, look at the thunderstorm sort of weather. It is just the bleh. And then afterward, you're like, oh, it's just so muggy again, like just sticky, gross. So again, down here, you can see the little suns. I like to think of warm air symbols as like little suns because it's bringing the warmth. Moving in this direction with the cool air ahead, and then you just have this nice little cloud development here. So those are warm fronts. Stationary fronts. It is literally what it sounds like. Stationary is so obnoxious. So this is where two air masses meet and neither is stronger than the other. So it's kind of like just butting heads the whole time. This can last for several days. This is like the week-long gross sort of weather in the summer. I like thinking about all of this in the summertime rather than the winter just because in my brain, it works. But anyway, so this will bring a long period of cloudy skies and light rain along the boundary. So this is where the air masses are moving in different directions. And they sit here and they just keep butting heads. One will not let go. The warm air is just warm enough to be considered warm, but not cold, and the cold air is just butting against, and they sit here. So this is where you get the cool air, so the little spikes or the icicles moving in one direction, and then you have the suns moving in the other direction, and they just sit here. So it's every other blue and red in the direction that the two air masses are moving. So if warm is moving towards the left, they're pointing to the left. If cold is moving to the right, they point to the right, and they just sit here creating this. So yeah, so there's that. Last front. So the occluded front. This is where like air masses kind of get caught with one another. They don't really blend as well. So blending maybe wasn't like the best word. But this is where a warm air mass is trapped between two cold air masses, and the warm air just kind of lifts up above it. This is going to bring really weird weather where it's like rainy one second, not the next, like all this. So you have two cold air masses which are living along the surface essentially, and they're moving relatively quickly. And if there was a cold air, warm air, cold air, the cold air tends to just kind of like catch up, and then the warm air sits on top of it. This picture just shows it the best. Okay, so moving really fast, moving with life, to where this cold air, because it's denser, it stays down below, and the warm air just kind of sits on top and gets like taken for a ride, to where everything is moving in the same direction. They're just not moving any faster than one another, except for this guy. He's moving just a little bit quicker to keep him up above. So again, you get that cloud development and all of this. Wherever you see a front, you're going to have clouds because it's essentially a warm air and a cold air meeting, and it causes condensation to happen. There's just no way around it. So that is just how much precipitation, how severe of cloud coverage and things like that. So that's what's kind of going on. So I'd recommend, if you haven't already, maybe grabbing a couple colored pencils so that you can truly fill in these symbols the way that they should be, or just make note of what's red, what's blue. This one is the one that tends to be purple when we look at it on a weather map, but sometimes it shows up like this, where everything's moving in the same direction, but every other blue and red. But yeah, these are things that are going to be helpful in the future when we start working a little bit more with predicting weather. But yeah, we needed to understand what's happening as our air masses are coming in contact with one another. So let me know if you have any questions. If not, enjoy the rest of your day. Hopefully we do have a nice high pressure system moved in. And yeah, let me know if you have any questions. Thank you, 8th graders. Have a good day.